Okay, we're back to finish example 3. We have found a rational root from our choices of plus or minus 1 and plus or minus 13. It ended up that we had the same value work twice, and now we're down to this quadratic. That's your goal. Get it down to a quadratic, and then if it doesn't factor, you can use the quadratic formula. Well, that's the situation that we're in here. This does not factor. So let's use the quadratic formula. As a refresher, the quadratic formula, x equals the negative of b plus or minus the square root of b squared minus 4 times a times c, and then we'll divide all of that by 2 times a. And the key to this is being able to identify your a, b, and c, substitute things incorrectly, and follow order of operations. Let's start by substituting in what we know. The negative of b is going to be a positive 6. I should not sidestep this part of the process. A is equal to 1, b is equal to negative 6 in our question, and c is equal to 13. I would always recommend that you make that list. So the negative of b is going to be positive 6 plus or minus the square root, and then we're going to do b squared, so negative 6 squared, please put that in parentheses, minus 4 times a, which is 1, times c, which is 13. And we're going to divide all of that by 2 times 1. So there's my initial substitution. And now let's begin to simplify. So we have 6 plus or minus the square root of negative 6 squared is a positive 36. And then we're going to do the negative of 4 times 1 times 13. So 4 times 13, again, I hope you have your calculator and you're participating along and not just copying. That's going to give us 52, I believe, all over 2. And we keep simplifying one step at a time. 36 minus 52. Again, calculator usage is helpful. Hopefully you recognize that that will be a negative. The negative under the radical, we're going to have some non-real answers here. And our denominator's 2. Not ready to do any reducing yet. Get everything simplified before you start to reduce. All right, the square root of negative 16 is 4, and then the I, all over 2. This is a situation where you could separate your fractions, or you can look for that triangulation between the constant out in front, any factor that you pull out of the radical, and then whatever your denominator is. So you have to have something in all three of those places that will reduce. So this gives us 3 plus or minus 2i, and our denominator is 1. And there are your remaining 2 roots. So we also have 3 plus 2i, as well as 3 minus 2i. There's your complex conjugates, the ones that have to travel in pairs. And here's our list of roots. Now we have one unique real root, but it's a repeated root, so that counts as 2. That's our x equals 1. And then you have the 2 non-real solutions for a total of 4, which is the target value that we were looking for with our exponent.